Hello grade 11, welcome again. With you Mrs. Minna Raouf, your chemistry teacher. Today we will continue chapter 21 and section 2 and 3, nuclear reactions and the nuclear tools. First we will talk about Sabar of Nucleus. Albert Einstein is the first one that realized the amount of potential energy that is stored in matter. He realized that mass and energy are equivalent and related by the following equation: E equal mc square. In this equation, E represents energy, m is the mass, and c is the speed of light, which equal 3 times 10 power 8 meter per second. Because the value of the speed of light is so high, you can see that the small amount of mass can be converted into enormous amount of energy. That explains why a nuclear weapon such as atomic bomb is so much more powerful than a weapon that involves only chemical reaction, such as a bomb made with dynamite. So this is because the amount of energy that is stored in matter. The nuclear fission. The nuclear fission is a splitting of atomic nucleus into two or more smaller fragments accompanied by a large release of energy. You know that changing the ratio of neutrons to protons can make a nucleus less stable. So here, adding a neutron to a uranium-235 nucleus can cause the nucleus to split. Atoms of two different elements are created along with more neutrons, and this is the equation that shows a uranium fission, where uranium-235 and 1 neutron will change it to barium-140 and krypton-93 and give off another 3 neutrons. During a chain reaction, each step produces a reactant for the next step. In the fusion of uranium, a neutron enters the uranium nucleus. As a result, the nucleus breaks into smaller nuclei. At the same time, it releases more neutrons, which are absorbed by other uranium-235 nuclei, and the reaction continues. So, the nuclear fission is a splitting of atomic nucleus into two or more smaller fragments, and it accompanied by a release of a large amount of energy. The nuclear reactors. The nuclear reactors is a device that is used to extract energy from a radioactive fuel by using controlled fission chain reactions to produce energy and radioactive nuclides. For example, the nuclear power plants, like the typical power plants that we talked about in the last chapter. This one uses a coal like fuel, but here in the nuclear power plants we use uranium-235 as a fuel. The nuclear power plants use energy as heat from the nuclear reactors to produce electrical energy. The nuclear fusion. The nuclear fusion is different from the nuclear fission, because the nuclear fusion is the process of combining two or more nuclei to form a large nucleus. So here we have combining of two or more nuclei to form large nucleus. In nuclear fusion, low mass nuclei combine to form heavier and more stable nucleus. And nuclear fusion releases even more energy per gram of fuel than nuclear fission do. In one common fusion reaction, two different isotopes of hydrogen combine to form helium and neutron, as shown in the following equation, where the two isotopes of hydrogen, one with mass number 2 is called deuterium, and one with mass number 3, which called tritium. This is two isotopes which have a small mass can combine to produce heavier and more stable nuclei. The helium produced here has a stable neutron and proton ratio, 1:1. So, the fusion is the process of combining two or more nuclei to form a large nucleus. Here's the difference between fission and diffusion. The fusion is a combining of two nucleus forming large nucleus. But here, fission is a splitting of a large nucleus forming two small nucleus. The nuclear tools. The radioactive nuclides in medicine. In medicine, radioactive nuclide like cobalt-60 used to destroy certain type of cancer cells, and another radioactive nuclide uses as tracer to detect the cancer and other disease, such as technetium-99 that used to detect the bone cancer. Hospitals are not the only locations where you will find radioisotopes. You have already read about several non-medical uses for radioactivity, like nuclear reactors, nuclear weapons, and radiodating techniques. Radioisotopes are also used in research and in the food industry. Now we have finished chapter 21. I hope you understood the chapter well, and don't forget your homework. Please check LMS and answer worksheet 3 and send it to me on our mail الواحة American Science Homework@gmail.com. See you. Bye bye.